Okay, so sorry guys, I'm trying to figure out what to do with this little thing. Okay, so maybe if I make it, there we go. Okay, so we are going through some summary stuff from your investigation. We have talked about a lot of this vocabulary before, but we're just gonna go through it one more time. Never hurts to do it again. So I've written out the general or standard form of a polynomial right here. Okay, n just represents whatever highest power you have. So maybe you pick 3, then you'll have a coefficient x to the third, you'll have another coefficient, and then 3 minus 1 is 2, so you'll have x squared. So it's just going to line everything up in descending order. Then it says the leading coefficient of a polynomial is, so remember that your leading coefficient is the number in front of the x term with the biggest exponent. Okay. And it's going to be the leading coefficient is the coefficient of the highest degree term. Okay. Those are just 2 different ways to say that. The degree of the polynomial is going to be the highest power of x. The constant term is the term with no x. Without, that's what that stands for, without x. Relative extrema are going to be maximums, maxes, or mins, or sometimes they're called turning points. It's supposed to be an R, sorry. Okay, so right behavior is going to be what y values do, or what y's do as x approaches positive infinity, okay? And left behavior is going to be what y's do as x approaches negative infinity. All right, so if I, let's see, drew out a function, okay, let me get some highlighters. So the turning points or the relative extrema are going to be like here or here. I'm going to highlight this in green. Okay, those are a max or a min. And then your left, or I'm sorry, right behavior is what y's do as x goes to infinity. So as I move right along my function, as x is moving in the positive direction, my right behavior is going up towards positive infinity here. And then my left behavior is what my little left arrow is doing. And it's going down in this particular case, it's negative infinity. Okay, so for part 1, our end behavior summary, if our degree is even, our left is going to be increasing and our right is going to be increasing. Okay, when it's even, they do the same thing. So I could have a function, left increases, right increases. We don't really know what happens in the middle. Okay, but we know that both our left and our right increase. For even, if our leading coefficient is negative, we're going to decrease and decrease. So again, I would have decreasing, decreasing. I don't really know what happens in the middle, but I'm going to decrease on both sides. If it's odd, it's going to start decreasing and then go increasing. So it's going to go down and then up. And we don't really know what happens in the middle. Something else could happen. And then if it's odd, but the leading coefficient is negative, it's going to do the opposite. It's going to increase and then decrease. Okay, so it's going to be going up. Something happens, goes down. Okay. Part 2, it has our terms and roots summary. So if our degree is 2, our max number of turning points is 1, and max x-intercept is 2. And remember that the max number of turning points is always going to be 1 minus this number. So we're going to have 2, 3, and 4, and then n for our degrees here. So this is going to be 2 and 3, and then n minus 1. And our max x-intercept is 2, 3, 4, and then n. Okay, so these two columns match. This column is one less than either one of those. Okay, and we get this number by looking at the highest value exponent. Okay, let's flip. So on the back, we have some practice functions. It asks us to sketch the graphs. So for the first one, we can see our roots here, here, and here. So we're going to have a root at -6. That comes from this. Oops, sorry. We're going to have a root at -2. That comes from this one. We're going to have a root at +1. Okay, so we know that we have to pass through this, this, and this point. We know our leading coefficient. Okay, so then, do you guys see how we have 3 terms here? Those 3 terms indicate that we are going to have a cubic function. Okay, if I distribute these two together, I would get a square, and then multiplying this x one more time is going to give me a cubic. Okay, or an x to the 3rd power. Okay, so, and that's just because we have 3 terms. If I had 4 terms there, it would be a quartic x to the 4th power. So because this is cubic, which has an odd degree, oh, look, there's a little table here. We have a negative leading coefficient. Our degree is 3. It's going to cross the x-axis 3 times because we had 3 different roots. Touch it 0 times because there's no power on any of those roots. And then, so because it's an odd degree and the leading coefficient is negative, we should increase and then decrease here. So we know what the endpoints look like. And then this y-intercept is going to be really helpful to find. To find our y-intercept, remember we sub in x equals 0. So I'm going to have negative 1 times 2 times 6. I just subbed in 0 for all of these. And this is going to give me positive 12. So my y-intercept is 0, 12. Okay, so I'm going to have a point up here at 0, 12. And in order to pass through all of these values, I have to connect like this. So this would be my function. All right. In number 2, I'm going to have positive leading coefficient. Now, this square means that this is going to have a power of 2. So I have 2, 3, 4 x's right here. So my degree is 4. It's going to cross the x-axis twice because neither of these have a power like this one does. So it's going to cross twice. It's going to touch once because right here we have an even power over this particular factor. And our y-intercept is where x equals 0 is going to be. So I'm going to have 1 times -2 times -3 squared. So this is going to be 9. 9 times -2 is -18. So I'm going to have 0, -18 right there. Okay, so let's go ahead and mark our roots. Our roots are going to be, we're going to have 1 at -1. We're going to have 1 at +2. And we're going to have 1 at +3. Oh, this one's going to be where it just touches. Okay, and then our y-intercept is going to be at -18 right here. So it's got a positive coefficient. Its degree is 4. So this means that both of our endpoints should go up. Okay. We are only going to touch right here. So this means that my function must do something like this. Okay. Then it asks us to write the functions in factored form. So down here, our leading coefficient. So clearly this has to be an odd function because the ends go in different directions. It decreases and then increases. So this means that our leading coefficient must be positive. It's degree 3 because we have two relative extrema, a max and a min. It crosses the x-axis one time and it touches one time, and its y-intercept is at 0, 2. Okay, so this tells me, based on the crossing and touching, that I have one, and this is at x equals -2, and this is at x equals 1, that I should have x plus 2 somewhere, and I need to have x, oh, that's not an x, minus 1, and this needs to be squared in order for this to occur. So this is our double root. Okay, so this is the best possible estimate that we could give for this function. If we sub in 0, I do indeed get that my y-intercept. Okay, and I can show that out. F of 0 is equal to 0 plus 2, 0 minus 1, quantity squared, 2, -1 squared, gives me just 2. Okay, over here, I have both going up, so my leading coefficient must be positive and I must have an even degree. I happen to have 4 roots and 3 relative extrema, so my degree must be 4. It crosses the x-axis 4 times, it touches 0 times, and my y-intercept is at 0, 0. All right, so we cross the x-axis at -1, so I'll have an x plus 1. At 0, so I should have an x. At 1, so I should have x minus 1. And at 3, so I should have x minus 3. Okay, so this is what we have so far. Let's double check and make sure our y-intercept works. If I sub in 0, notice that my x right here will be 0, and it's multiplied by all the other terms. So it forces the entire thing to be 0. If that confuses you, I'll go ahead and show it out. 0. So I'm going to have 1 times 0 times -1 times -3, but anything times 0 is just 0. So this does work for our y-intercept. All right, I hope that was helpful. I will post both this and the hard copy of the solutions. Good luck.